So far we've talked about propagating uncertainties when one variable is a function of another. We're now going to talk about combining variables. Let's say we have some variable a, which is equal to the sum of two other variables. The question then is, what is sigma a if you know sigma b and sigma c? Now you might think that this is pretty straightforward. You could just, the highest value of a is going to be when b is at its maximum and c at its maximum. So you could say the expected value of a is just b plus c, the highest value would be b plus sigma b and c plus sigma c. So put this plus that together, that will give you the maximum of this. And then you could find the range the way we've done before. But there's a trouble with that. If these two variables, b and c, are independent of each other, then sometimes they'll add up, sometimes both b and c will be higher than the average, sometimes they'll both be lower, but a good fraction of the time one will be higher and the other one will be lower, so they actually at least partially cancel out. So what this means is, in situations where you're combining multiple variables, and, crucial point, if they are independent, the combined uncertainty is less than just the sum of these. In fact, the equation you need to use if you're adding or subtracting, so if a equals b plus c or a equals b minus c, is what's called adding in quadrature. Sigma a squared equals sigma b squared plus sigma c squared, which gives you a result that's sigma a is generally more than either one of sigma b or sigma c, but not as much as both combined. And that's because they often partially cancel out if and only if they are independent. Similarly, if a equals b times c, or b over c, you do something very similar. In this case, the percentage errors add in quadrature, so sigma a over a squared equals sigma b over b squared plus sigma c over c squared. So once again, you're adding in quadrature, but now you're adding the errors divided by the average value, so that's the fractional errors. So when you're adding or subtracting, a equals b plus c or b minus c, it's like this. That's a plus regardless of whether you're adding or subtracting up here. And whether you're multiplying or dividing here, it's like this. Again, that's plus regardless of whether it's multiplication or division.